All right, so this question was taken from the June 2008 Pure Mathematics, paper 2, and it says, given that the log to base A of BC is X, log to base B of CA is Y, and log to base C of AB is Z, where A is not equal to B, which is not equal to C, prove that A to the X times B to the Y times C to the Z is equal to A, B, C all squared. So to do this question, we just have to remember the definition of logarithm. Just to write it on the screen, remember the definition states that the log of a base of a number is equal to a power, and then it implies that base to the power is equal to the number. Cool. Hey! So in this case, all we're going to do then is, this is saying that A raised, so here it is, A raised to the power X is equal to BC. What else we're seeing is B raised to the power of Y is equal to C times A. And then C raised to the power of Z is equal to AB. So if we were to multiply all of them together, so A to the X times B to the Y times C to the Z, that's going to be equal to BC times CA times AB. And as we do that right there, we know that A times A is A square. That becomes A square. And then the B times the B becomes B square. And then the C times C becomes C square. And so this becomes A, B, C all square. And that's it right there. Nice and easy. That wasn't too bad. That was from 2008. All right. Now this question says solve for x in the equation log base 2 of x plus 2 over log base 2 of x equal to 3. Wow, go ahead and solve this log equation. So pause the video and attempt. All right, go ahead and attempt it. Now a question like this, you should be looking and just laughing at it because this is clearly in a form that resembles a quadratic. So what I want us to do is start by maybe calling y equal log to base 2 of x. If we call y log to base 2 of x, then this equation looks like y plus 2 over y is equal to 3. Easy. So then we can multiply through by y. And so this equation is going to become y squared plus 2 is equal to 3 times y. We can then bring over the 3y to the left-hand side. So the equation becomes y squared minus 3y plus 2 equal to 0. Now, once we get to this stage, we can go ahead and factorize. So we can go ahead and factorize now. Signs are the same, both of them negative. So it's going to be y, 2, and 1. Minus and minus, because the plus means signs are the same, and this means both of them be negative. So in this case, we're getting y is equal to 1 or y is equal to 2. But remember at the start of the question, we said y is log to base 2 of x. So this is saying that log to base 2 of x is equal to 1, or we're saying that log to base 2 of x is equal to 2. So in that case now, we just need to find x. By using the definition of logarithm, this is saying x is equal to base of 2 to the power of 1, or this is saying x is equal to the base of 2 to the power of 2. So the answers are x is equal to 2 or x is equal to 4. That's the answer. X equal 2 or x equal 4. That's how we would take on this question. Nice and easy. So right here, we got the answer to be x equal 2 or x equal 4. Now, what I love to do, anytime you're doing a logarithm question, before you finish, I love when you actually take out your calculator and just verify it. You're doing the question pretty much, you're doing the question and you just always want to see that you're correct. So taking out our calculator, we're going to go log base 2 of when x is 2 plus 2 over log base 2 of 2. And we should get 3. Ah, look, we got 3. So we can definitely conclude that 2 is correct. Let's check when x is 4. When x is 4, we're also correct. All right, beautiful. All right, so that's how we would have tackled this question taken from June 2006. Nice. All right, this was also a part of the 2006 question here. It says solve for x. We have 3 to the x equal 5 to the x minus 1. Solve for x, and it's only 3 marks. Anytime the unknown is in the power, you take the log of both sides. Always remember, whenever the unknown is in the power, we take the log of both sides. So this is going to become the log of 3 to the x is equal to the log of 5 to the x minus 1. Hey! Laws of logarithm then tell us that we can carry down the power. So this is saying x log 3 is equal to x minus 1 times the log of 5. Now we need to then go ahead and make x the subject. So on the right-hand side, we can expand in x to get x log 5 minus the log of 5. And that's equal to x log 3. Now, once you get that, you need to make x the subject. So bring all the x on one side. So we can bring the log 5 over to the left and bring the x log 3 over to the right. We're just transposing. Once we do that, we can then factor out x right here. And we have x times log 5 minus log 3. And that's equal to log 5. And so we can divide both sides by log 5 minus log 3. Just to use a different color to show the canceling effect. It's always beautiful when we use a different color. So let's go with black. This cancels this. And so finally, we can write that x, this is the answer, x is equal to log 5 over log 5 minus log 3. All right, you can simplify your answer if you want. No, I will just leave it as it is. You can also put your answer in decimal, but I'll leave it as this. X is log 5 over log 5 minus log 3. That's your answer. All right, so just write it beside the question. X is log 5 over log 5 minus log 3. You won't lose any mark. Now, just to verify that it is true, let's go ahead and check it. You know, I love when you take out your calculator and check to see if it is indeed true. So look what we're doing here. We're bringing out our calculator and we're going to have 3 raised to the power of, let's get out our fraction. This is log 5 divided by log 5 minus log 3. When we work that out on the left-hand side, we get 31.86. All right, so when x is this particular value, we got 31.86. Let's check and see if the right-hand side will also give us that same value. All right, so remember it was 5 to the x minus 1. So just going to put a minus 1 here and change the number 3 to 5. Look at that. We still have 31.86. So we'll see that our answer is correct. All right, so we're nice. All right. Now, this is the second part of the Pure Mathematics June 2008 log equation. And it says find the value of x such that log base 5 of x plus 3 plus log base 5 of x minus 1 is equal to 1.